Hello everyone, welcome to my YouTube channel. Today let us learn about design and analysis of algorithms. So the contents we study today are: what is algorithm, criteria to design algorithm, selection sort, algorithm of selection sort, working of selection sort, time complexity of selection sort. So let us learn about algorithm. What is algorithm? An algorithm is a step-by-step procedure to solve a problem in a finite number of steps. Branching and repetition are included in the steps of an algorithm. This branching and repetition depend on the problem for which algorithm is developed. All the steps of algorithm during the definition should be written in a human understandable language which does not depend on any programming language. We can choose any programming language to implement the algorithm. Pseudocode and flowchart are popular ways to represent an algorithm. So let us learn about criteria to design an algorithm. There are 5 types of criteria. First one is input. An algorithm should have 0 or more but should be a finite number of inputs. We can also say that it is essential for any algorithm before starting. Input should be given to it initially before the algorithm begins. Second one is output. An algorithm must give at least one required result from the given set of input values. These output values are known as the solution to the problem. Definiteness. Each step must be clear, unambiguous, and precisely defined. Finiteness. Finiteness means algorithm should be terminated after a finite number of steps. Also, each step should be finished in a finite amount of time. Fifth one is effectiveness. Each step of the algorithm must be feasible, that is, it should be practically possible to perform the action. Every algorithm is generally expected to be effective. So let us learn about selection sort. So what is selection sort? In selection sort, the smallest value among the unsorted elements of the array is selected in every pass and inserted to its appropriate position into the array. It is also the simplest algorithm. It is an in-place comparison sorting algorithm. In this algorithm, the array is divided into 2 parts. First is sorted part and another one is unsorted part. Initially, the sorted part of the array is empty and unsorted part is the given array. Sorted part is placed at the left while unsorted part is placed at the right. So where the sorting starts from left to right. In selection sort, the first smallest element is selected from the unsorted array and placed at the first position. After the second smallest element is selected and placed in the second position. The process continues until the array is entirely sorted. The average and worst complexity of the selection sort is O of n square, where n is the number of items. Due to this, it is not suitable for large data sets. Selection sort is generally used when a small array is to be sorted. Swapping cost doesn't matter. It is compulsory to check all elements. So let us learn about algorithm of selection sort. Algorithm of selection sort uses array and n number of items. So the output is into non-decreasing order, that is a of 1 to n. So the for loop I starts from 1 to n, then j will be equal to 1. For k is equals to I plus 1 to n, then if a of k is less than a of j, then j will be equal to k. Exchange a of I with a of j. So let us learn about working of selection sort. First, now let's see the working of selection sort algorithm. To understand the working of selection sort algorithm, let's take an unsorted array. It will be easier to understand the selection sort by an example. The unsorted array is 12, 29, 25, 8, 32, 17 and 40, where the index values will start from 1, 2, 3, 4, 5, 6, 7. So now for the first position in the sorted array, the entire array is to be scanned sequentially. At present, 12 is at the first position. After searching entire array, it is found that 8 is the smallest value in the array, where I will be in the position of 12 and j will be in the position of 12, where j searches for the smallest element in the array. It is found that 8 is the smallest element in the unsorted array. So swap 12 with 8. After the first iteration, 8 will appear at the first position in the sorted array. So 8 will come in the first position, that is first position. So now I will be incremented, that is k is equals to I plus 1. For the second position where 29 is sorted presently, we again sequentially scan the rest of the items of the unsorted array. After scanning, we find that 12 is the second lowest element in the array that should be appear at the second position. Now at the second position, k is 29, that is I plus 1, where when it is scanned whole unsorted array, we found that 12 is the lowest element, that is j. Now swap 29 and 12. So after the second iteration, 12 will appear at the second position in the sorted array. So after two iterations, the two smallest values are placed at the beginning in the sorted way. So 8 and 12. So 12 will be in the second position. The same process is applied to the rest of the array elements. Now we are showing a pictorial representation of the entire sorting process. So the next step is, there is 25 in the third position where k is equals to I plus 1, and j starts searching for the smallest element in the unsorted array. It is found that 17 is the smallest element in the array. So it swaps 17 and 25. 17 will come to the third position of the array. So the next step is 29 is in the fourth position, that is k equals to I plus 1. J starts searching for the smallest element in the array. It is found that 25 is the smallest element in the array, that is j. So now swap 29 and 25. 25 comes to the fourth position of the array. In the next step, it is 32 in the fifth position where k is equals to I plus 1. It starts searching for the smallest elements, that is 29 equal. J will be 29. So we have to swap 32 and 29. So we swap 29 and 32. 29 is in the fifth position. 32 and 40 is already sorted, so we don't need to swap anything. So this is the complete sorted array. Then the array is completely sorted. So let us learn about time complexity of selection sort. Best case complexity. It occurs when there is no sorting required. That is, the array is already sorted. The best case complexity of selection sort is O of n square, where best case complexity occurs where there is no requirement of sorting. Average case complexity. It occurs when the array elements are in jumbled order, that is not properly ascending and not properly descending. The average case time complexity of selection sort is O of n square, where average case complexity occurs when the elements are not properly even in ascending order or in descending order. Worst case complexity. It occurs when the array elements are required to be sorted in reverse order. That means, suppose you have to sort the array elements in ascending order, but its elements are in descending order. The worst complexity of selection sort is O of n square. So thank you everyone. Do watch whole video, like, share and subscribe my channel. Thank you.